Good morning, everybody. Welcome to Natural Science Week 6. We're doing fuses and short circuits. And I'm going to take you through it. Ground rules, remember, we're only going to talk about context specific on the chat. Cameras will be off and we'll be respectful of each other at all times. That means no bad language. Okay. So I hope you enjoy the lesson and learn a lot. If you have any questions, you're welcome to ask me. You just have to raise your hand and I will ask my host to unmute you. Okay, so by the end of this lesson, you'll learn what a fuse is about, what a short circuit is, how fuses are used in every day, and then I'll introduce you to magnets because our lesson tomorrow would be on electromagnetism. Okay, so a quick recap on what we learned yesterday. We learned that current is the rate at which charges move. The charges are electrons, so current is the rate at which the charge moves or flows. An electric current transfers energy to the particles in a light bulb filament, and this produces light that the filament emits. Okay, so an electric current, it transfers energy to the particles in a bulb filament, and this produces light. And this is what makes the bulb light up. As electrons move through a resistor, they encounter a resistance, okay, and they transfer some of their energy to the resistor itself. So you saw in the last section, when we looked at the filament of the light bulb and the element in the kettle. So the energy went to these and it made it work. Okay, and then we also learned a new word, which was an ammeter. And an ammeter is used to measure the current in a circuit. So let's say you don't have a light bulb, or if you want to test if your plugs are working, or if you want to test something has an electric current in it. So we basically use an ammeter to do that test. Okay, we also learned that all conductors show some opposition to electric current. So in a circuit, there is some sort of opposition, and this opposition is called a resistance. So the resistance basically prevents the flow of current to go through. Kihara, your question? You had your hand raised. I'll ask my host to unmute you. Hi. Okay, so I'll continue until you do get unmuted. There are several factors that affect the resistance of a conductor. Okay, so these factors are the material, the length, the thickness, and the temperature. So in your test, if they ask you, name 4 factors that affect the resistance of a conductor, this would be your answer. It would be the material, the length, the thickness, and the temperature. And if they say name 4 factors and give an explanation, then you're going to say material. For example, copper, it has a lower resistance than steel. And you're going to say length. The longer the wires, the greater the resistance. And then if it says thickness, then you're going to say a small diameter has a greater resistance. That means because it has a smaller diameter, that means more current can pass through. And then we have temperature. The heating a wire increases its resistance. So basically, if the more heat in the wire, this increases its resistance. So there are 2 main ways of increasing the current in an electrical circuit. And you can do this by increasing the voltage or by decreasing the resistance. So basically, if you have to increase the voltage, that means you're increasing the flow of current through the circuit. And if you had to decrease the resistance, that means that you use a lower resistance, so more current can pass through the resistor. So Okay, and if you had to, I did explain it, so I don't have to read this to you, but I'll read it anyway, just to reinforce it. So this means that increasing the voltage will cause the current to increase, okay? And if you increase the resistance, it will cause the current to decrease. Okay, so remember, increasing the voltage means an increase in the current, and a decrease in the resistance means that the current will also increase, but if you increase the resistance, then the current will decrease. Understand? So there's two different things here. Decreasing the resistance means that you're increasing the current, but increasing the resistance means that you are decreasing the flow of current. Right. So in this activity, we just demonstrated how a fuse basically works. And we're going to learn more about what a fuse is. Now, in the experiment that we did yesterday with the steel wool basically acted as a fuse. So when the current was too high, the steel wool melted and it prevented any further current. Okay, so remember that when we closed the switch and then the steel wool mixed with oxygen and it melted, so this prevented the flow of current and it broke the circuit. So basically, we actually say that the steel wool acted as a fuse because the current was too high. Now, if you had to give a definition of a fuse, like in the test, sometimes they can ask you basically explain what a fuse is, or they could list a whole lot of different components, like an ammeter, a fuse. You later learn about a voltmeter, and then they'll list it in a table form: 1, 2, 3, 4, 5, and then they'll mix it all up where you have A, B, C, D, E, and then they mix all the definitions up and then they ask you to match and write the answer in column C. So that's one of the techniques they use to test definitions, so if you know it. So we say fuses are special wires which break the circuit when they overheat and melt. So we say fuses are special wires which break the circuit when they overheat and melt. And they are safety devices that reduce the danger when using electricity. So we say that they are safety devices that reduce the danger when using electricity. So basically, fuses break a circuit, and it breaks the circuit because it will prevent overheating and melting, and it is used as a safety measure. Okay, and it's a safety measure because it reduces danger. Then we're going to continue. The heating effect of an electric current can be very dangerous. If a circuit overheats, it can cause a fire. So to avoid overheating, circuit contains fuses. So sometimes at home you would notice, like for example, everything went well, not like ESCOM when they put the power off, but like for example, if your trip switched or something happened, and basically everything goes black. And then if you go to investigate, it could be overheating occurred in some appliance and your fuse blew. And the blowing of the fuse, you mustn't take it as being, oh God, it's just a major inconvenience. You must rather take it as, thank you, God, you saved us from something worse from happening. So that's the function of the fuse. It's there to protect you, to protect your home, and to protect your appliances from overheating. So fuses contain a low resistance resistance wire made of metal at a low melting point. Therefore, the piece of wire melts if it gets too hot, just like the steel wool in your activity. So if you look here at the picture, you will see this metal and it's coiled because it basically increases the length to increase the current. So what happens is this is attached to your circuit, and if the current is too much, then it will burn off, it will break, and it breaks the circuit. So you could see that you can say it has a low melting point inside this wire here. Okay, so before I explain, if you look here at the picture at the bottom, this is the symbol of a circuit, of a fuse, sorry, you use in a circuit. Nati, my host will unmute you. Oh, sorry, it was Levi. You're using your brother's name. Yes, Levi?
Ma'am, I also read it in my natural science textbook. It also shows like to choose the right fuse of an appliance. You must first know the working current of the appliance.
Yes, that's very good. Excellent. Well done on the good research that you're doing.
Thank
So
you.
when you are choosing your fuse, you have to check the voltage of your appliance, and it protects you, because if you use a very, very low fuse, then it's not really going to work. So it has to match with the voltage and the current flow. And this protects you as well. Thank you for that, Levi. It was very good of you.
Thank you.
Okay, you're welcome. So we have different currents. They need different strengths. Um, Different circuits need basically different strength circuits. So then we need different types of fuses. So as Levi said, that you need to know the strength of your circuit, then you know what type of fuse to buy. Okay, some fuses can only handle a little bit of heat, and then some can handle a lot of heat. So we choose the fuse that suits the safety needs of the circuit. And if the circuit overheats, then the fuse will melt and it will break the circuit to reduce the danger of fire, as well as protect electronic equipment. So you can relate this to your pair of shoes. Say, for example, if you're a size 4, if you put on a pair of size 3 shoes, it's going to be too small. If you put on a pair of size 5 shoes, it's going to be too big. So you need a size 4 shoe because your foot takes a size 4 and you'll fit comfortably in it. So it's the same way fuses work. So you have to choose the right fuse for the right strength of current. And then it completes your circuit and it will make it work. Okay, so when we draw the fuse made if how would you draw a fuse? So now basically the conventional drawing which I showed you earlier is this rectangle here, and it has two wires at the end. So this is your symbol for a fuse. So you can Google my previous lessons as well, and then take down those symbols if you haven't already, and then learn what the symbols are. And as we're going along, I'll introduce you to more symbols. Okay, so it is important to never remove a fuse from a circuit without switching off the current, because you will get shocked and this would prove to be very, very dangerous. So you must never just um, uh, touch electrical appliances or just remove things because without switching it off. You must always switch at things off before you actually um, uh, remove it from the circuit. Like for example, if you have a hair dryer and you put it into the wall socket to dry your hair, then you don't just pull the socket, the plug out. You must always switch it off and then you pull your plug off. It not only protects you, but it also protects your hair dryer from getting damaged. Because remember, if your switch is on, current is still flowing through. Okay, even though you may have switched the hair dryer off, it's still flowing into from your wall socket into the hair dryer. Yeah, if your wall socket is not off, the current is still flowing through. Okay, so never just pull a plug off. I'm repeating that. Always make sure you put the switch off and then you pull the plug off. Okay, so we spoke about circuits breaking, and because if a fuse blew. So what do we basically mean? What is a short circuit? Okay, so a short circuit can occur when an electric current takes the path of a low resistance. So we're saying basically a short circuit occurs when electric current takes the path of a low resistance. This is, for example, when a conductor is connected directly to both the terminals of the battery. So you have the positive terminal and you have the negative terminal. So have you ever heard that something broke because it short circuited? So I'm sure most of you in your home or in your functions that you may have had when there's lots of electricity being used, somebody would have said, hey, there was a short circuit. So a short circuit basically happens when another part is accidentally made into an electric circuit. So we introducing another part that is disrupting your flow of electricity. So when we mean the path, it offers very little resistance to the electric current. And there is so little resistance that the current flows along the short circuit and it doesn't pass through the main circuit. So what happens is that there is so little resistance that the current flows through the flow along the short circuit and it doesn't pass through the main circuit. And short circuits can be dangerous and it can cause a lot of damage to your appliances. So basically, um, when the current flows through the short circuit and it doesn't go through the main circuit, it can be dangerous and it can actually damage your appliances. Like sometimes when there's lightning, uh, your circuit, because of that extra current that is flowing through, then your appliances get damaged as well. This is what basically happens. So when have you ever had a piece of toast? Like we take a simple example, and if it gets stuck in a toaster, and sometimes this is really a real nuisance. It's like a big problem and a little bit irritating. So lots of people they tempted to use their butter knife to unhook the bread, and because they feel it's just easier to unhook your bread when your toaster gets stuck. But don't be tempted to do this because your knife that you're holding, your butter knife, especially if it doesn't have a plastic at the end, because some knives they do have that plastic at the end. I think Levi, you have a. I'll ask my host to unmute you just now. So your knife is a conductor. That means provided that your whole knife is metal, and it will act as a short circuit. So all the electric current will flow through your knife, and because you are touching that knife and you holding that knife, especially if your toaster is on, it's going to flow through you and you will get shocked. So it's very dangerous to use a butter knife to unhook your slice of bread when it's in the toaster. Levi, I'll ask my host to unmute you now.
Isn't it you said that like the short circuits can also be dangerous?
Yes,
Um,
it can.
because most of the short circuit cases often occur from loss of insulation.
Yes, now you see what happens is when it short circuits sometimes, it damages your appliance because that flow of electric current is broken, and that's how your appliance gets damaged because
Mm.
it can be too much going through at one time because there's like a sudden movement now. Like, if you, for example, if somebody um, comes in the back of you and you don't know and they say boo and then you get a shock. So this is basically what happens when that circuit breaks. Your appliance gets a shock and that's how it can damage your appliance.
Ma'am,
Okay. Uh, any other questions? Okay, so we're going to continue. We're going to say how are fuses used in everyday circuits. So let's find out. So there are different types of fuses. The one that we investigated will require you to replace the fuse if the wire melts. However, so that means, for example, all the fuses that we discussed so far, If your fuse basically gets burned, then all you have to do is to replace the fuse. So now some fuses, they work differently to break the circuit, and it can be reset once the problem in the circuit is fixed. So for example, if you have a problem in your circuit and it's not the fuse, then your fuse is going to keep on blowing and breaking until you fix the actual problem in the circuit. So your fuse also gives you an indication that there is something wrong and you need to fix it. So if you had to replace a fuse and if you still have a problem, then that means that there's something wrong with your circuit and you have to either send it in for fixing. And if you're good at it, then you can try and fix it yourself. But sometimes it's better to send it in for fixing because professional people, they are able um, to solve the problem very, very quickly. Um, so let all of us, we live and we work in environments where electricity plays a major part in our lives. And um, we need flexible energy sources that are easily transformed into other forms. So we live in a world that is basically technology based. Like for example, like how this the problem that we're experiencing in the world now. So what solved the problem in educating you was this online digital learning that you have. So can you see how electricity is involved because you need your appliances charged so you can learn. So technology has basically improved our lives in such a way that you can now learn online as well. And you have these lessons, so you're not really losing out the information that you're supposed to be learning in school. So and you're gaining that experience still, and you're still learning. Okay, so now you know that we need electricity to charge our appliances, and it's an integral part in our lives because imagine if you had to live when you actually know when Eskom cuts our circuits, then what happens to you? You basically left with nothing to do. And this is where you learn to go and play outside again and enjoy the environment. And so we need also to find the balance between electricity, appliances, and outdoor environments where we can live a balanced life. Because sometimes if you sit on your computer the whole time, it's not good for you. When you go out to play in the sun, you're getting vitamin D and it's very healthy for you. So the circuits that are wired in a house by an electrician will start with wires coming from the power lines. So for example, let's say if your fuse has broken, so what happens, the electrician comes to your home and he goes to investigate to find where the problem is. And he'll start with your power lines to see where the electricity is flowing from. He'll go to your circuits. Every house has a circuit board and your mains. And whenever you have a problem, and if it's like a very big problem, the first thing you should do is to switch your mains off. Because when you switch your mains off, it cuts all the power in your house, and it can actually prevent a fire. So if something happens in your home, for example, and if you see like a circuit broke, like your toaster and or your oven or something, and you can see that it's making noises like sizzling noises or something, then the best thing for you to do is to put your mains off or that switch in your main board off, and call an electrician, and then they'll be able to solve the problem. Uh, it's very important that you do that. Okay, so I'll say circuits that are wired into your house by an electrician, they start with the power lines outside and then they connect it to your fuse and to a meter. And then the meter is basically to take the reading of how much electricity you use every month. And then that information goes to the electricity department and then they bill you accordingly. Or some people buy prepaid electricity. So the meters, like if you are using a meter, meters record how much of electricity you use, and therefore you will be charged on that amount of energy. And meters are basically used, are sold, are used and sold and measured in kilowatts. And you use kilowatts per hour, how much of kilowatts per hour you are using. Okay, so the fuse boxes contain safety devices called fuses or circuit breakers, which are designed to prevent electrical fires and overload of electrical current. So these because the electrician knows how much of current your home would need, and this is why they put the fuse by your meter. So it's there to protect you. When the electric current is too large, an electromagnet attracts a spring load switch, which breaks the circuit and it cuts the power supply. And the switch must be reset before the current can flow again. So you see the word electromagnet. I'm going to explain it to you. First, I'm going to explain what magnets are, and then I'll explain what electromagnets in the next few slides. So a safety tip for you, a circuit breakers and fuse can prevent electrical fires and overheating that can be caused by an overload of electrical current. So we have circuit breakers and fuses. They basically prevent electrical fires. And electrical fires are caused by overheating, okay, or an overload of electrical current. So this is important for you to know as well. On your wall plug, don't put too many appliances on one adapter. Make sure that it is just a few appliances a few appliances per wall plug, because if you overload too many appliances on one circuit, then it's going to cause a circuit break. So most modern homes have circuit breakers instead of fuses. A circuit breaker is similar to a fuse in that it is designed to protect an electric current, or to protect the circuit from getting damaged, or it's due to an overload of a circuit. And this basically stops the flow of current. Now, unlike a fuse which melts and then um, you just replace it. But a circuit breaker can be reset to start operating again. And you can manually do it, or you can automatically reset the circuit breaker. So we're going on to magnetic effect. I said that I was going to explain what it is to you. But before I explain, let's look at the bottom. This is a magnetic bar. So in the magnetic bar, you can see it's red and it's gray. So if you look at it closely, it has, because it's written sideways, this is actually N, which means north, and this is S, which means south. Yes, Levi? I'll ask my
Uh,
host.
I was,
Yes?
ma'am, I was about to say that opposite poles will attract each other and the same will repel.
Very good. Very good, Levi. So
Yeah.
we say opposite poles attract each other and like poles repel each other. That's also what we learned in our previous lessons about atoms as well.
Mm.
Um, Very good. Well done, Levi.
Thank
Before
you.
we look at how a current produces a magnetic field, let's learn about magnets. So a magnet is basically a piece of material which produces a magnetic effect. And a magnet has a north pole, as you can see in the red, and a south pole, which you can see in the gray. So very important for you to remember is that opposite poles attract each other and the same poles repel each other. So another word for same poles is like poles repel each other. So a magnet has a magnetic field around it. So around this magnet, there's basically magnetic field all around it. going in all directions. So you need to learn opposite poles will attract each other and like poles repel each other. Um, can my host unmute one participant? No, someone has a question.
Ma'am,
Hi.
I want to say, ma'am, what type of metal is a magnet, ma'am?
That's a very good question. Let me see. Hi, Levi, you had a question? Hi, Levi.
Ma'am,
Yes.
uh, it's a, we also learned in technology. I think it was last year. They also we learned that also the Earth has its own magnetic.
Yes,
It has its own magnetic field.
yes, you're very correct with that. And I'm going to explain it to you in the next slide. So a magnet is made out of iron. So the metal that is used to make a magnet is iron. Anyone else has a question?
Hello, ma'am.
Hi.
Ma'am, I just wanted to ask that magnet in the picture, is it a permanent or a temporary magnet?
Okay. Um, I would think that it would be a permanent magnet because it's not changing, but we're not going to talk about permanent and temporary magnets now because we're doing electric currents and then I don't want to confuse other learners. But I
Yes,
can get some more information and I can tell you about it in later lessons, but not now. Is that okay?
yes, ma'am. Thank you.
No problem. Okay, so now so did you know that the Earth is a bar magnet with a north and a south pole? So as Levi said, the Earth basically has an electric magnetic field around it, which basically gives you your north pole and your south pole. So the Earth has this basically gives us the compass. You know, when we have a compass, this basically tells us directions because the Earth has a magnetic field around it. So a plotting compass has a needle with a little magnet. So if you look at, I'm sure you've looked at compasses in previous grades, and you would see that compasses, they have a small magnet in it. And this is, and the poles that give it deflects is basically because of the magnetic field all around the Earth. So the needle points to a magnetic north because the small magnet is attracted to the opposite magnetic pole. And this gives you the direction of where you are. So the Earth has a magnetic field as though there was a big bar of magnets running through the core. So if you look at the picture, this big bar of magnets is not actually there. Okay, it's just to show you. So it has the magnetic field is like similar, okay, like a big bar where you have the north pole and the south pole, and um, and you can see through these lines. This is how the magnetic field is all around it. So we're gonna talk about what electromagnetism is. Electromagnetism is basically a branch of physics, and it deals with an electromagnetic force that occurs between electrically charged particles. So um, basically, electromagnetism, there's an electromagnetic force. Now, if you look at the word electromagnetic, so there's two words in it. So there's electro and then there's magnetic. So that means it has an electric force and a magnetic force. So electromagnetic force tells you that there's an electrically charged particles in it. So the electromagnetic force is one of four fundamental forces that exhibits on electrical magnetic fields, such as magnetic fields, electrical fields, and light. And it's a basic reason why electrons bound to the nucleus and is responsible for the structure of a nucleus. So remember in matter and materials, and I showed you pictures of um, atoms. And inside the nucleus were your protons and your neutrons. And then on the outside in each shell or each level, there were electrons. And I told you that these electrons were not moving randomly around the nucleus. They moved in harmony with the protons. So the reason why they moved in harmony was because of the magnetic field in that atom. So those electrons moved according to how the protons moved. So now you can relate that to your atoms. So when we go back to doing revision next week, you'll be able to understand a bit more. So what is an electromagnetic force? An electromagnetic force is a type of physical interaction that occurs between electrically charged particles. It acts between charged particles and is the combination of magnetic and electrical forces. So we could say that an electromagnetic force can be attractive or repulsive. So in your test, if they ask you for 3 marks or 4 marks, what is an electromagnetic force? Or they're not going to ask you what is, they're basically going to tell you, discuss how an electromagnetic force works. And maybe it would be a 3 mark or 4 mark question. So this is what you would say. Then another, before I can tell you, then another way of them asking you is to summarize how an electromagnetic force works. So you will say, the electromagnetic force is basically, you're going to say, a physical interaction that occurs. So it's a physical interaction occurs between, so you must write, between electrically charged particles. And then you will write, it acts between charged particles and is a combination, it has a combination of magnetic and electrical forces. Okay, and then you can also say that it has attractive forces and repulsive forces, where you can say like poles repel each other and unlike poles attract each other. So another way of discussing it is we say electromagnetism is the study of an electromagnetic force and one of the 4 fundamental forces of nature. It includes an electric force, which pushes all particles, all charged particles, and a magnetic force, which pushes only moving charges. So very important for you to know is that the in an electromagnetic force, it pushes all charged particles and the magnetic force, and it only pushes moving charges. Okay, so I have homework for you today. In your homework, I want you to find out about common household appliances. So you're going to look at choose an appliance that has a fuse, and then you're going to write it down. Which appliances have a fuse? And then you can research it. You can Google these appliances as well, and then you can write it, does it have a fuse? So common household appliances which uses fuses. So you can use internet as well, because I'm sure you won't know off by heart. And then you're going to write a paragraph describing the appliance and explain why a fuse is necessary for that appliance. So it's basically, by you doing this homework, you're actually summarizing what you've learned today. So the importance of a fuse and why you have to use it and you have to relate it to the circuit of the appliance you decide to use. Okay, that's your homework for today. I'll leave it on for 30 seconds for you to write it down. Right, so we're going to summarize what we learned today. So we learned that a fuse acts as a device to break a circuit. Please cameras off. A fuse acts as a device to break circuits in case of a fault or overload in the circuit. And a fuse is an electrical device which is used in order to protect the system or equipment from overcurrent, so that the fuse blows open and it will open the entire circuit and it will stop the current from flowing. So this is part of your answer that you can have. I can repeat it. A fuse acts as a device to break a circuit in case of a fault or overload in the circuit. So a fuse is an electrical device. So you need to know that it is an electrical device that is used to protect the system from overcurrent. That means also to protect the system from overheating. So the fuse blows and the circuit will open and stops the current if there is too much of current for that system. Then the other concept that you learned today was electromagnetism. So it's the study of an electromagnetic force. So you must know that this is part of nature because the earth has a magnetic force around it. So this electromagnetic force, it includes an electrical force and it includes a magnetic force which pushes moving particles. Okay, so the electrical force and the magnetic force, it works together and it allows the moving particles to move. What you can do is, all the information from this tutorial, it was sourced from cvela.com, and the Department of Education uses this as their workbook. But you can Google this site here, and it explains electromagnetism if you want to know more about it beautifully. Because tomorrow I'm going to do chemical what am I doing tomorrow? Tomorrow we're going to do the magnetic effect around a conductor, and I'm going to teach you how to make an electromagnet. Okay, so and then on Friday we're going to do a chemical effect, and then on next week Monday we're going to start with revision. So if you want to contact me for any information, you can do so at ahaffea@gmail.com. And thank you so much for staying through the tutorial. I hope you benefited from this learning experience. And I'll see you tomorrow here, same time. Goodbye, everybody, and have a lovely day.